Hi, this is Steve, V6WZ. Let's talk about beverage maintenance, problem detection, and prevention. These are four of the main ways a beverage will fail. Either a lost feed connection, and I consider this to be fairly obvious on receive. That is to say, your radio will pretty much go dead. Usually the cause might be a blown matching transformer. If there's been a lightning hit, it'll take out the primary or secondary winding rather. I mitigate that by using gas discharge tubes across the secondary. Or you could have a bad or broken connection. And for bad connections, I make sure I always inject my F connectors with silicone gel and basically infuse the connection and to prevent water ingress into the connector. A lost coax feed, again, is also obvious on RX. It could be a cut or damaged coax from animals, machinery. The way to mitigate that is bury your feed lines, and for sure use flooded coax. I have experienced this from animals, in particular deer chewing through my RG6. The third thing is a lost termination, and this is one of the two which are less obvious on RX. When you're receiving on the beverage, you will still be able to hear, you may not even notice by listening to the radio that you've lost your termination. Usually from a blown resistor through a lightning strike. Again, I use a gas discharge tube across the resistor. I described this in my other video regarding how I build my both feed and termination boxes. Or it could be a bad connection or in fact a broken wire. Now, in fact, that leads to the fourth thing, which would be a downed beverage wire, and it also is less obvious on RX, even if the wire is broken. It's usually more common in a treed area. What I do is use a counterweight system to prevent that breakage, and I've described this in more detail in my field installation video. Here's a quick video of the method I use at my termination. I have a counterweight concrete block on a marine grade pulley so that and the feed line, the feed wire going to the termination box is coiled up so that if a tree falls down here, as shown in this diagram, basically the cement block will rise up, the wire will move out, and the feed line will extend outwards without disconnecting from the termination box. Real easy fix. I go out, cut the tree down, and the wire snaps back, and it's an easy fix. But again, will not be obvious when listening to the radio. So again, lost termination and downed wires, those two things are not obvious on RX. In other words, the radio is not dead on receive. So therefore, we need to physically walk the lines to know if there's been a problem. Otherwise, we don't know. The thing is, here at V6WZ, and I'm sure there's others as well, I've got 12 beverage wires, and they average maybe 850 feet long. I mean, some are up to 1,000 meters, and others are 800 meters. Some are shorter at 750 meters. And that totals about 10,000 feet on average, or 2 miles, 3 kilometers of line. And that's not counting the distance between the lines. So, I mean, if I walk each line out and back and then add the distance to the other wires, the total walk is going to be over 5 miles or 8 kilometers. And on top of that, my terrain is very heavily treed and hilly. So, to walk all of my lines and inspect each termination and feed point, it can take me up to 3 hours easily. And that's in the summer. And I mean, it'd be even longer in the winter, where I got to be wearing snowshoes because of the deep snow. And on top of that, I mean, I've got 4,000 feet of coax feed lines in the field. And I mean, if I lose a feed line, how do I find the break? So this is a diagram, a satellite view of the V6WZ location. The white square in the middle here, that's where the shack is located. The beverage lines, of course, are shown in lines. And so these, just shows the distribution of my beverage wires. And so, you can see it's all trees. So it's a major effort to be to have to go out and inspect each of these lines to see if there's a problem. So, and I'll put on top of that, my station is remote, so I need to drive 100 kilometers or 1.5 hours just to visit the station. So I need another solution. How do I evaluate my beverages remotely? Well, the solution I've come with too is I use the AIM antenna analyzer to sweep each beverage antenna from the shack to identify problems. For sure there'd be other analyzers that might work, but I find the AIM and I was able to modify it to be turned on remotely. and I can save files and compare them to new sweeps. And the TDR function on the AIM is very effective for sweeping the feed lines to find faults. Plus, I had an AIM analyzer, so that's another reason why I'm using this device. Shown in the picture is the AIM 4300, which is the latest model. I use the 4170, which is the earlier model, but I think they're very similar. Now, you know, this is not a trivial problem. I mean, some might think this is a solution looking for a problem, but listen, even from a base station, a non-remote, if you've got beverages and, you know, being able to quickly inspect your beverages regularly, or for sure after a storm, a heavy windstorm, or before a contest is extremely helpful. You know, being able to isolate and locate problems for a quick fix is a huge time saver. You know, how do you locate a cut feed line that an animal's chewed through in February when there's 3 feet of snow? You know, and you know, are all my wires still up? You know, before the CQ Worldwide CW. So this is a real important issue as far as I'm concerned to be able to do this. So here's an example of one of the sweeps, and I'm going to show you how I gain these sweeps. This is from the software that comes with the AIM analyzer. It's actually an image of my JA beverage wire sweep from 1 to 8 megahertz, and you can see the SWR is plotted here in red. And I'm going to talk more about this and show you how I gather these with the AIM and how I compare them to saved files. But first of all, what's the setup I use? Okay, well, this diagram here shows the shack in this box. Okay, this box indicates my shack at the remote. So I have my PC, and connected to the PC is the AIM 4170 analyzer. And the analyzer, I've modified it to allow me to use a relay at the remote to power the AIM on or off. So I can turn the AIM analyzer on. The output from the input for the AIM has an RG6 line going to this selection switch. It's a really simple relay. It's a simple signal relay which is normally closed to send the RG6 coax coming from the beverages to my radios. So normally all of the beverage feed lines are always going to my radios. But by activating the relay in this box, I will then be sending all of the beverage wires into the AIM. And that's how I remotely toggle the beverages to the AIM so I can analyze them. The rest of is basically my switching system. It'll be different for everyone else, but you know, I have a box located in the shack which selects either the east box or the west box, and each of those boxes have 4 beverages from them. So there's a total of 8 directions, although you know, I have an EU broadside phased pair and a north broadside phased pair and a broadside pair phased to the west and a pair to JA. So I mean, each of these have 2 wires. Okay. Now, one last thing, of course, my PC is always accessible via TeamViewer or any other remote desktop application connected through the internet, through the WAN, and into the to the cloud. And of course, so therefore, I mean, I can use my iPhone and with the TeamViewer app, access my PC and evaluate my beverages at any time. In fact, I can be in the field with my iPhone, accessing the PC in the shack, and I can make adjustments to my beverage. I can, in fact, be at my termination on any one of my beverages and remove the termination and do a sweep, and I can actually, you know, see what's happening when I do that. Of course, I'm at home. I use my PC at home with TeamViewer, and I can analyze my antennas, my beverages, and if I'm away on holidays, again, with my laptop with TeamViewer loaded, I can evaluate my beverages. So let's have a look at what the setup looks like. I'm going to show a quick video of how it's set up in the actual remote shack. Here's the switch box that I built to affect the switching of the beverages, which are normally coming in here with this RG6 line and are normally routed to the radio. But in this box, I won't open it up, but dead bug mounted on the lid here is an Omron signal relay, which is driven with this 12 volt line here at a relay at the remote. And when that's activated, it switches the routing from the radios to this coax line, which goes to the AIM analyzer, this RG6 line. And it goes down to the AIM, which is permanently installed here at the remote, unless, of course, I use it for actually doing some antenna work. But it's mounted here at the remote. It's connected to the PC through a COM port. What I also did was I tapped 2 wires off of the momentary on-off switch in the device.
so that I can pulse a relay here to turn the device on and off. So therefore, remotely accessing the PC here, I can turn the device on and activate the other relay so that all of the beverages can be analyzed and inspected for both any kind of damage to the wires or even the feed lines.
This is an image of the PC at the remote station. Currently, I am sitting at home about 100 kilometers from the remote station, and I'm logged in using TeamViewer, a remote desktop application, and controlling the PC at the remote. In the upper right here is my Denkove application, which controls my 16 relay Ethernet control board. And here in the middle, you'll see the AIM relay indicated, and I've toggled that on. Now that's activated the relay, which I just showed in that video, which is now sending all of the beverage coax lines directly to the AIM device. And to the left, this is a pulsed relay. I'll activate that for 2 seconds, and that pulses and turns the AIM device on. In the compass dials down here, this particular dial here controls my beverage direction. And I'm going to slide this over here. And that's because I have two PCs at the remote. And this is my main PC that I use to control the radio and operate. But I also have another PC at the remote, which I use to where I have the AIM software loaded, and for various reasons. And so I just want to be able to access my relay direction controller. And so this window here, this one here, is actually my other PC. And so now let's bring up the AIM software, which is shown down here, and we'll bring it up. And so this is the software that is used to drive the AIM device. It's program version 910B, which I think might be the latest version. I'm not sure. So the basic setup for the AIM. First of all, I do have a calibration file, and I can say load a calibration file, and I have a calibration file here called East Box Cal, and I'll load that. This is a calibration file which is actually calibrated to the end of the coax out in the field at the East Box, and in fact, I used my TeamViewer application by accessing this PC that I'm at now with my iPhone while I was in the field, and that's how I created this calibration file. The truth is, I really don't think it's necessary to calibrate your feed line at the end of the coax. I don't think that's required. I think if you just let your AIM be calibrated at the box in the shack, that'll be adequate. Since we're not in this case looking to derive exact parameters. It's more you're looking for changes, and you'll see as I proceed along here how that works. So as far as the settings, so set up your plot parameters. I'll plot the SWR and the ZMag and the series load. All of them. I don't usually bother with return loss and these others. It gets a little bit too busy. One other thing, make sure that you've set it up to your ZREF to be 75 ohms, of course, because that's your coax. And as far as the limits, I'll set it from 1 to 8 megahertz. That seems to provide a good cross section of bandwidth all the way up to 8 megahertz to help identify any problems. So we've set it up, and so for example, let's sweep. So if you'll notice here to the right, I'm selecting the northwest. That's the Japan wire, and if I now just go scan. There's a scan of the JA wire, so you can see what that looks like. Now, what you can then do is save this file. So you can go Save Graph, and you can enter a comment if you like. I usually don't bother, and then you give it a name, JA wire or whatever you choose for that particular beverage wire, and save it as a file. All right, so that's what I've done for all of my beverages and continue to do. So then what you can do is you can load a graph. So in this case, you'll notice I have a folder with beverage scans October 2018. Now these are a bunch of scans that I made back in 2018. So I can load, for example, my beverage northwest scan. So that's the same wire. And then what I can do, so I can load this. Then I can say, all right, let's rescan this same wire. And I'll do a rescan. And you can see that it's a pretty good match. There's a slight change here, but more or less this is a good match. So I know that everything's okay. So if I did that again, let's load the JA wire. Now, So this is normally what the JA wire looks like. Now, I unfortunately haven't actually saved a faulted wire. I mean, I've had probably 5 trees fall on my wires, and it's very obvious when it happens. So I'm just going to pick an example. Let's just select the east wire to sort of give you a sense of what it might look like. So you'll notice here, this is what it might look like if a wire is down or a tree is fallen. You'll notice that's just not a match. So I know something's wrong with this wire, and I'll go out and check it. It's fairly clear. Now, another thing I did do was I made a number of scans with when this very same JA wire, for example, lost its termination. So this is what the JA wire looks like without a termination. So let me do that again. I'll load the JA wire, yeah, I'll load the JA wire. This is normally what it looks like, and then what I'll do is overlay a graph, and I've saved this one. This is the same JA wire when I disconnected the feed line. All right, and that's what it looks like with no feed line. So it's very clear when you've got a problem with your feed line, and of course in this case, you'll also know that on receive, because you won't have any audio on your receiver. Now, what about if I've lost my termination? So I can overlay a graph. Let's have circles, and so this is what it looks like if I lose my termination. So in this case, it's less dramatic, and in fact, if you've got the radio hooked up, you're still going to think it's a live radio, but this is clearly there's something wrong, and so this is a clear indication that there's a problem with the radio, or I'm sorry, a problem with the beverage. So there you go. That's a quick and dirty look at how you can save your files and compare them to saved files and determine if there's a fault. I'll just give a quick video of what it looks like in the field when I've lost a wire.
Here's a typical example of a tree down. Let's see if you can see the wire here. This happens to be my east beverage, going up to the tree, to the insulator. This tree came down, and it was very clear doing the sweep with the AIM analyzer that the parameters were way off, so something was wrong with the east beverage. But I also saw that there was a problem with the south beverage. And I don't know if you can see here. I'm going to try and work my way over. But this tree, having brought down the east beverage, it's really close to a crossing right there for the for the south beverage. And so, since it was on top, it came in contact and brought down somewhat the south beverage as well, and of course that completely upset the AIM sweep. And there it goes under the tree. So, time to get the chainsaw out. But as I've explained in the other videos, this is a perfect example of the benefit of having the counterweight at the end with a concrete block on a pulley, because this wire did not break. Neither of the wires broke at all. Just get my chainsaw out here, and I'll cut this tree up, and the wire will spring back, and we'll be good to go.
What about broken or cut feed lines? I have almost 4,000 feet of coax feed lines. Some of them are buried, but a lot of them, especially in the bush and in the forest going to the various boxes, are just lying on the forest floor and under logs. And in fact, in the last 2 years, I've had 2 failures, both from animal cuts, either deer or moose. In fact, this is an example of one of the cuts I had right at a beverage box. You see on the left here, this is where the coax entered the feed box, and I don't know, a deer must have just been chomping down on and mistaken this coax or included it while biting a branch, and just cut right through the coax. In fact, in another case, this is a diagram showing the where the shack is located here in white, and then in orange is at one of my main trunk lines going out to what I call the west box. That's this box shown in yellow. Well, I lost all of my beverages coming off of the west box, and it turns out another deer or a moose bit right through my coax here partway out, and it was in the middle of the winter, covered in snow under a log, and somehow the animal got to it and cut it in half. So how do we find that? How do we locate that? Well, we use the TDR function on the AIM analyzer or any other analyzer that has that function. That's what I'm going to talk about here. So this is the east box that I have here in this diagram. That the shack is shown in green, and so I have a coax line, a feed line, which runs out to the first yellow box is the splice box, and then it goes to the switch box here, labeled east box, and from the east box, then of course it goes to the north beverage wire, to the east beverage wire, to the southeast beverage wire, and also to my broadside phased pair to Europe. And so this is what it looks like when we do a TDR sweep with the AIM. In fact, this is a number of sweeps overlaid, and you can do this and save the image, and that's what I've done here. A distance is on the axis along the bottom, and impedance on the other axis. So the sweep clearly shows the first impedance bump here is the splice box at 125 feet. So that's the first yellow square here. And then the next big jump, this is the bump at the actual switch box, which is out 287 feet. Then you'll see another bump here on the green line. That's the east beverage box at 332 feet. The purple bump, that's the southeast beverage box. Impedance bump, and then the north beverage box, which is quite a bit further out here, it's out at 491 feet, and then the last bump here, the Europe phased box, is in the blue line, okay, and that's this longer coax line. So here's the thing: if I were to get a break and all of a sudden find this goes dead, I'll get if the line breaks, I'll see a sudden sharp reflection wherever that line is broken, and I can literally, using this, having saved this graph, I know I can measure exactly how many feet past the splice box it is. Or for example, if it happens to be this feed line to the European beverage, I can select that wire and see where the bump is and measure how many feet from the switch box it is, and accurately locate where that line break is. Super handy and super convenient. Just for those that haven't worked with TDR, time domain reflectometry, that got this out of Wikimedia. It's a great little image, but essentially TDR is the device will send out a pulse, and wherever there's an impedance change, there will be part of the signal will be reflected back, and the amplitude of the reflected signal will be a function of and depend on how great the impedance change is, and that's why I even see small bumps just at the point of my switch boxes and splices. Let's have a quick look at how I measure these and how I set up the analyzer to take these measurements. Just as I showed before on the antenna sweeps, I'm logged into the remote PC and I've brought up the antenna analyzer, the AIM software program. So to use TDR, the first thing we need to do is make sure that we load what's called we have to load a calibration file, and it requires what's called a standard calibration file. You can read the manual to explain how that is. I've saved one at the box. It's called atbox acal. And then here under TDR, we turn TDR mode on. Okay, that's the first thing we do for the setup. Then what we'll want to also do is select our velocity factor. It's shown here, and in this case I'm using 0.83 as my velocity factor of most of the coax lines. I have a bit of a mixed coaxes out there, but 0.83 is the average velocity factor of most of my lines. As for scales, I like to use somewhere around 1,000 feet distance. You can adjust this according to how long your lines are. You can go all the way out to 2,000 feet, and I will use that sometimes. And the impedance, you'll fiddle with this to get a nice presentation on your scale. 200 ohms is appropriate for what we're doing now. So again, like I did before, to the right here is my beverage switch box. So let's select, say, let's select the southeast beverage. This is my east box, and then we effect a scan. And there's the result. So as I shown in that image, this first bump is my splice. I know that that's a splice about 125 feet from my from the shack, and then this big bump is the switch box, and then this next bump right here, that's the actual beverage feed box right there for the southeast beverage. Now if we look to the, now what you should do is, once you've done a sweep, you save this graph, and so you can save the graph like this. You can enter a comment if you want, and then save it, and it's being saved as a TDR file. You'll notice I have TDR info. This folder has a number of my sweeps for every wire, so I have that on hand. The importance of that is once you've saved this, then if you got a coax break anywhere along here, you would then just compare your coax line to current coax line to this one, and you could see where the break is and measure, for example, how many how many feet it is from any one of these known spots. So let's go to the right here again. Let's sweep the east line. So what we do is a rescan, and it'll scan right on top of it. This is the important thing. You can do a rescan. So you could bring up an existing sweep of what you know that the coax should be, and then bring up a current one with a rescan. So there we are. You notice, of course, the splice is in the same place, and the switch box is in the same place as it should be. But now in green, like we just swept, this is the actual east beverage box feed point. Okay, that's my bump there, and it's a little bit closer than the southeast box. What if I do the north box? This is my beverage going north, and I'll do a rescan on that, and the same thing. And we'll get a scan for that. And there you can see the same thing. Everything's the same right up to the switch box, but the blue line now, this is where, and if you notice up in the top right corner, in red is showing the distance up here. This is the distance where my cursor is, 486 feet. From the shack is where that where the north feed box is located. And then of course I can do the same with the northeast box, my European box, which is where I have my European phased pair. So pretty simple. The very important key here is you save these files, build a file, and then you've got them, and knowing what it should be, if you get a break, you'll be able to accurately locate where that coax break is. If you have broadside phased beverage arrays, it's a little more difficult to sweep each individual wire in the pair and or identify problems on the feed lines. And that's because when you there's two ways to feed a beverage broadside pair. In both cases, we have equal length coax lines that come to the center and are basically put in parallel. Of course, when you put two 75 ohm coax lines in parallel, we're left with 37.5 ohm impedance, and we step that up through a 2-to-1 transformer and end up sending it to our 75 ohm coax to the rig. The other method is using what's called a 0-degree hybrid combiner. Same thing's happening. We're basically combining these two 75 ohm outputs, and the same step 2-to-1 matching transformer is required. In both of these cases, the problem is, of course, they're always tied together, and if a fault happened on beverage 1, we would be unable to isolate which of these two beverages had the problem. The same would be true if one of these coax lines got a cut. I wouldn't be able to isolate and locate which line had the problem. So what I did was I designed this circuit, which is the same 0-degree hybrid combiner and the matching transformer here going to our rig. But I basically included relays on both beverage 1 and beverage 2, which when powered up through power on the coax, I power this through 12 volts on the line. Then when this is activated, then beverage 2 will be out of the circuit, and vice versa. When this relay is active, then beverage 1 will be out of the circuit. So it provides an easy way to isolate each wire. I designed this with KiCad and designed my own circuit board and had it made and made it so that it would fit in a small aluminum Hammond box. Well, here's what happened. I made an error in designing this, and that's because this was my first TDR sweep, and this is exactly where the splice box is, where the switch box is. But as soon as I isolated one antenna, I ended up with a huge reflection and no information beyond the phase box. Well, that's because, going back to that circuit, if you'll notice when this relay is activated, then we have no impedance on this side of the hybrid combiner. So that ends up with a hard TDR reflection. When I designed this, I knew I was doing that, but I wasn't too worried about the mismatch since it would have been nominal. I might have been losing a dB. But I realize now that that gives us a problem with doing the TDR and isolating the individual beverages. So I redesigned this circuit to look like this. So I basically now have the combiner being the common, and when it's active, it will then activate through a 75 ohm termination resistor. So now when this is activated, it's terminated in its characteristic impedance, and that way we will now not have a hard reflection, but it'll be a soft reflection since it'll absorb the energy on that line. So here's what it looks like when I do a TDR sweep. Through my phase box. So you've seen this before, but this is my splice box. This is the switch box right here at 287 feet, and here is the EU phase box at 530 feet. Now, if I isolate EU1 only, this is the blue line, and you can see there now, this is the feed line going to the European #1 beverage line at 736 feet. If I then toggle the switch and do another sweep on the EU2 beverage, you can see that it's, it looks like my lines weren't exactly the same length. There are just a few feet different, so I wasn't careful enough when I cut those two feed lines, but they're close enough. So now, and by the way, the red line is when they're both together. So here we go. So this is 200 feet from there to there, which is exactly what they are. Those are my 200-foot feed lines. My beverages are spaced 200 feet apart. So again, this is so now as I've shown here. So this is where the feed box is, and I now can isolate both this feed line and this feed line if there's a fault, and I can isolate and sweep each wire at any time to determine if there's a problem with them. So in summary, if you've got beverages, consider deploying your antenna analyzer to check your antennas. It's easy to do after a windstorm or before a contest, and it's really a lot easier than physically walking all the lines and inspecting things. And this, in my opinion, this method is not of trivial value, especially for a broken feed line, which can be hard to find without TDR. I know that from experience. That one line which I had, I never would have found it in the middle of the winter if I wasn't able to just look at the sweep and identify how many it was. In fact, I know it was 110 feet from the one splice box, and I just measured it out and started digging in the snow and found my faulted line. The key, though, to do this is to save baseline sweeps for each wire, because a downed wire will be really obvious. But if you haven't saved the sweep, you won't know. You won't be able to tell the difference. It's all about comparing it to a baseline. If you already have an AIM analyzer or similar suitable analyzer, why not put it to use? The fact is these antenna analyzers, they're a little bit pricey. But for me, this utility, using this thing, makes them extremely useful day to day in the ham shack. In other words, it's not just for occasional antenna work. This has become part of my shack. And I don't know. I'm almost inclined to say the AIM is the most useful test instrument that I have in the shack. Well, okay, maybe it's second to my multimeter. Anyway, 73. This is Steve, V6WZ.